Welcome to Brain Vision.
Hi there. In this question, we have a cube, and our cube has the dimensions 1 centimeter by 1 centimeter by 1 centimeter. Since it's a cube, the length, the width, and the height are all the same. And we want to know, first of all, how many platinum atoms we can put into that cube. After that, we then want to calculate the radius of a single platinum atom. We're trying to figure out how many atoms are in this platinum cube, or how many platinum atoms can fit in this cube. We have been given some information about platinum in this problem. We know its density, and we know the mass of a single atom. We can use that information to calculate how many atoms are in there. Let's see what I mean by that. First of all, I need to know the volume of this box. We know volume is length times width times height. Since this is a cube, all three of those dimensions are the same. It's 1 centimeter by 1 centimeter by 1 centimeter. Or, in other words, the box is 1.0 cubic centimeters. All right, I'm going to use that volume of the box and the information given in the problem. So we have 1.0 cubic centimeters. That's the volume that we have for this space. We are given the density of platinum. The density of platinum is given as 21.45 grams of platinum in every cubic centimeter. Look what that'll do for us. That will get us to grams of platinum, because centimeters cubed will cancel. We are also given the mass of an atom of platinum. That information is 3.240 times 10 to the negative 22nd grams. So grams will cancel. So if I solve this now, I will have number of platinum atoms. That is going to be 6.6 times 10 to the 22nd. I rounded to just two significant figures because our initial measurement of the box was only given in two significant figures. All right, so this is our answer for part A. This is how many atoms are in that box. In part B, we want to know the radius. And atoms are, of course, spheres, so we can use the equation that tells us volume of a sphere. But before that, we need to know the volume occupied by a single atom. In other words, I am trying to find the volume of one atom. Well, I just calculated in part A. I found out in part A that 1 cubic centimeter of space in that box is occupied by a total of 6.6 times 10 to the 22nd atoms. So if I divide by that, that will tell me how many atoms per space. But hold on, we know that atoms are spherical, so there's empty space in there. In fact, we know that for every cubic centimeter of space, only 0.74 cubic centimeters are taken up by the platinum atoms, because they told us only 74%. So 0.74 of 1 is 74%. All right, so let's look at what cancels here. Centimeters of space cancels, atoms cancel, and I am left with the volume per platinum atom of 1.12 times 10 to the negative 23rd centimeters cubed for every platinum atom. Okay, I will round to the correct number of significant figures when I get to the end of this calculation because I want to keep those same two significant figures. But for now, we will leave it as is. And we are ready to calculate the radius of a single platinum atom because volume is equal to 4/3 pi r cubed. That's the formula for a sphere. And we just calculated the volume of a single platinum atom. So I can solve for radius. So let's rearrange this equation. Radius cubed is going to be equal to 3 times the volume divided by 4 times pi. Let's get a little more writing space here. All right, so let's plug in some values here. 3 times that volume that I just calculated, 1.12 times 10 to the negative 23rd centimeters cubed, divided by 4 times pi. This gives me a radius cubed of 2.67 times 10 to the negative 24th centimeters cubed. All right, but I just want r. I don't want r cubed, so I'm going to take the cube root of both sides using my calculator. I'm going to take the cube root, and I will get that r is equal to 1.4 times 10 to the negative 8 centimeters. All right, so that's the radius in centimeters, but taking this one step further because the problem asks us for the answer in picometers. So in every centimeter, there is 1 times 10 to the 10th picometers. That means our answer is going to be 1.4 times 10 to the second picometers as the radius of a single platinum atom. And that makes sense. It's 140 picometers, which seems to be right in range with the average size of atoms. So that is our answer for part B. 1.4 times 10 to the second picometers would be the radius of a platinum atom. Thanks for watching.